Hello dear students, I hope you are doing fine and I welcome you in this online tutorial session after your Terminal 1 exam. You have really done good performance in your Term 1 exam. I am very much satisfied and let us continue it in the same manner for our Term 2 preparation. And as you know that syllabus for your Term 1 was chapter 8 and 9. So now chapter 10 and chapter 11 are going to be your syllabus for the coming term, as most of the portion of chapter 12 is already been removed from your syllabus and half of the chapter 10, second half of this chapter 10 is mainly removed. So we are left in this chapter 10 with Newton's law of gravitation, which I also discussed with you in yesterday's lecture, and along with this it is important to discuss the numericals which are related to Newton's law of gravitation. There are other numericals which are based on free fall, which are exactly the same way you can solve those numericals like you have solved in previous chapter using equations of motion. But you need to understand the concept of Newton's law of gravitation and how the force changes when distance between two masses is changed or when the masses are changed itself. So let us start with the equation of Newton's law of gravitation, that force between two masses is equal to capital G m1 m2 divided by r square, where m1 and m2 are the masses and r is the distance between their centers. So let us consider masses here, m1 m2, and r is the distance between their centers. Then force on one is equal to force on other, and gravitation is always attractive. So what is the tricky point here? From this formula you know that force is inversely proportional to square of distance. So which means if distance becomes half, force does not become half. If distance becomes half or force does not become double, if distance becomes half, your force becomes 4 times, and it is the point where students do mistake. Let us understand it in simple way. Let us consider r dash is the new value of distance, which is half the original value. So what students do in hurry, they think that it is r by 2, so 2 will come up in numerator and force will become 2 times, and they forget to do the square of the r which is there in the formula. So you do this numerical exactly in this same sequence, do one extra step so that you can avoid the mistake. So let us say r dash is the new distance, which is half of the original distance, and let us say f dash is the new force which we are going to calculate corresponding to new distance. I will also make image here for you. Now distance between these two masses is reduced to half of the previous distance, r dash, where r dash is equal to r by 2. Now f dash will be the new force between them, which we are going to calculate. Apply the Newton's law of gravitation exactly in the same manner on this new distance r dash. F dash is equal to G m1 m2 divided by r dash and its square. Now in second step, you put the value of r dash in terms of r. So G m1 m2 are exactly like they were in this relation and divide by r dash. So in place of r dash I will write r by 2. So r by 2 and then whole square. In next step you can write for f dash like G m1 m2 divide by r square, and this 1 by 2 which is having square will become 4 and will come in numerator. If you compare it with the original equation, you will see that G m1 m2 by r square is my f, original force between the masses. So using this equation, first equation in this equation, let us say this is your equation second and this is your equation 3. So using first equation, G m1 m2 by r square is f. In equation 3, f dash will become 4 times f. So please pay close attention to this procedure. When your r is becoming half, your force is becoming 4 times, and your force is not becoming double. If distance is becoming half, force is not becoming double, force is becoming 4 times. Similarly, in the same manner, if your distance will become double, your force will become 1/4 time of the original and not the half. So I will solve one more numerical for you. So here numerical is what should be increase in distance for having gravitational force reduced to half of its original value. So like previous numerical, you just first simply write the original case, that F is equal to G m1 m2 by r square. Let it be your first equation always. And now as it is given you that force is reduced to half, so it means according to question it is given that new force F dash is equal to half of original force F. And let us say R dash is the new distance between the masses. So if you will write the formula for new force F dash, you will write it like G m1 m2 divided by R dash having square. This is your equation 2. Now according to question, it is given that new force should be half of the original force, which means F dash is equal to half of F. So I can write this F dash as equal to half of F. So if I will write it as half of F, so I can write it half and then the value of F, that is G m1 m2 by r square, where this value is the original force. F is equal to G m1 m2 by r square. So F dash is equal to half of F. So I place the value of F in this equation, and F dash my this is F dash. So in these two equations, what you will observe, your G m1 m2 will cancel out by G m1 m2, and what you will get 1 by r dash square is equal to 1 by 2 r square. Or what you can write them, you can write them like r dash square is equal to 2r square. Taking square root both sides, your r dash will come root 2 times r, which is your answer. So what you conclude from this numerical, that for having half the force, distance is not required to increase to double of its value. Only root 2 times distance is sufficient for having value of r dash new, for having value of new force to half of the original value, if the distance is increased to root 2 times of original distance. The key aspect is, because in the formula of Newton's law of gravitation we are having r square, so if I will write root 2r at the place of r and I will be having whole square, the square of root 2 will become 2 and square of r will become r square. So your new force will become half of the original force. Take care of this point. I am telling you, go through this video again and again. This is the very common mistake which students do when they are solving the numericals for Newton's law of gravitation, like what is the value of distance, or how much distance is to be increased if the force is to be reduced to half, or how much distance is to be decreased if force is required to be double or 4 times the previous value. So I will also be discussing this with you in the live classes. So go through this and then we'll continue in next lecture. Like always, thanks for watching. Take care. Bye bye.